So my name is Niels. I'm a part of the product management team at Neo4j. And what I do is this area here. So this morning, Alex, very briefly, do I have feedback on my mic or no? We're good? Okay, so this morning, Alex very briefly told us about the different parts of the Neo4j ecosystem. And this is where I live mostly, on the tooling side. So we have a bunch of tools you may have used, including the browser, Bloom, dashboards, but also some of the newer ones like data importer, document intelligence, modeling. What we also do is, for example, drivers or even APIs. So this is all part of kind of the tooling that makes the graph database usable. Right. So I want to look a little bit forward based on where we are today and what the plans are for Neo4j as a company and where we want to go with tools. And I think whether you like AI or not, right, we have to admit this is the reality of things, the future of tools. It will be agents using it alongside of humans. It will definitely not be only agents. I think it might be a 50-50 thing. But we need to make tools that can be usable by agents. Just last week, I was speaking to the documentation team at Neo4j. They were having a little existential crisis saying, are we writing docs for humans or are we writing docs for an agent to just crawl through? And it's the truth, right? If you are testing a new product today, many people are lazy. They'll just point an agent at it and say, go figure it out, right? I don't want to bother reading documentation. So yeah, let's embrace that and let's build products that work both for agents and for humans, right? So on the left, we have the traditional tools that you've all been using, browser, data modeling, which we are, of course, also investing heavily in. We're making this better, easier to use. We're hooking them up together. And what we're doing now, starting actually last month, is we're combining these tools into a single suite, which we call the Studio. So the Studio is just a wrapper of the existing tools that work nicely together. Then on the right side of things, we are talking about the agents, and agents don't use UIs. They like to use APIs and MCP servers, et cetera, et cetera. So yeah, I think Jean-Marc will show more on that side. But I think we have to have these side by side. And of course, they might intertwine as well. So an agent might generate a dashboard, which then a human will view, right? So this is really how we're looking at tools this year. And what this means in practice is that we're doing a lot more API-first development and making things work for both of these consumers. So then a little bit about Studio. So this is what I just said, right? We're thinking about our tools a little bit differently. People don't usually use one tool. They don't usually use browser, dashboards, query. They're using a package of them, and they are equally important. So what we've done is we've bundled this up, called it Studio, and put this in our three main deployment scenarios. On the one side here, there's desktop, which is our offering for individuals to try on your local machine, set up some stuff, run some Neo4j. So you've got all the tools, but you're always working alone. You're always playing by yourself. You're testing, right? So this is, of course, super important, but this is not what enterprises need. Enterprises would like to work in a collaborative environment that's more secure. And then we've got two options here for the enterprise side. There's Aura, which is our cloud offering, which has the same tools as desktop, but a little bit more. We've got agents, we've got document intelligence coming soon. And the big advantage of Aura is then you've got these collaborative functions. You can work on dashboards together. You can share them with each other. And what we've now done as well, and this is something that's available July 2026, which is yesterday, is the self-managed side of things, which we call Enterprise Studio. So people that have used self-managed Neo4j, they had to install Bloom before, they had to install NeoDash before, they had the browser. Right now, you just have one thing that you install. You run it once, it all works together. So I'll do a little bit of a demo on the Studio. But yeah, so what we're effectively trying to do is build the same tools, ship them everywhere, and make you use them. All right. Yeah, so as I said, the difference here in what people used to do before and what they do now, instead of running all these things separately, keeping them up to date, you just have one thing that you update once, can talk to multiple Neo4j instances. It uses the same functionality base. It has the same visualization software. It's kind of the same package, right? And on the bottom one here, I think this is also very important, more on the technical side, the tools all store objects in the same way. So a dashboard and a Bloom perspective and a query and a model, those are all stored in the same way. They're shared in the same way, and you can interact with that in the same way. So quickly, before I go into the demo, where we are with the three main tools today. So this is the Neo4j browser. So if you've used Neo4j, there's a 99% chance you've seen this, right? This is the classic UI for data loading, for doing some simple querying. And what we've done with the browser, and you'll see this in a bit, we're doing some changes to the layout. So we're making a tabbed view, which is more similar to an IDE. We've improved the visualization a lot, which is now using NVL. And we're also building AI copilots, which means writing natural language and converting that to Cypher, which is really quite cool. And then the browser also stores Cypher queries, safe ciphers, that then also are in Studio, and that you can eventually also share with other people. On the Bloom side, we've also been making a lot of updates. The way that styling works, theming is being simplified, the concept of perspectives is being worked on, and also Bloom is getting a lot of improvements in terms of collaboration and sharing. So it's much easier to share your explorations with other people and groups. On the dashboard side, which is my main product here, we've also been doing a lot of work on interactivity. We even have a feature now to generate an entire dashboard with AI, which is very cool. I'll show that in a little bit. But again, making dashboards, putting that in the hands of not only technical people, but also this more citizen analyst roles. All right. So with that said, I would like to ask to play the video, and I'll do a quick demo. I was not brave enough to do it live, so I'll just talk over the video, but it's me. I did this 2 days ago. Right, so what I did here is I wanted to show you how Studio works with all the tools combined. So what I'm doing is I'm uploading a bunch of CSV files into our data modeling tool, and then I'm asking AI to generate a model for me. So this is a feature that we built a couple months ago. So let's see if I can find the button. Yeah, I think I'm here. I'm just inspecting the different tables to show you what the data looks like. This is a supply chain data set, right? So then I clicked to generate a data model. Instead of giving it instructions, I went for the going in blind mode and said to the AI, you figure out the data model. So what it's now doing is it's inspecting the schema, it's looking at the data, and it's going to come up with a model very, very slowly. It should take about 15 seconds because it's trying to look at the schema, do some sampling. And you'll see in a little bit, hopefully, that this will make a very nice model that combines all these different data sources in a graph. Here we go. Right, so here's my supply chain data set. We've got products that follow recipes. Products are made in batches. Suppliers supply the products, and then distributors are distributing the products. So it made a very nice data model completely automatically. It created indexes and constraints as well. And what I'm going to do now is I'm going to click on Run Import on the top right. There we go. And then I'm going to choose my instance, and I'm going to let Neo4j completely handle the transformation from the CSV files to a graph, which, if you've ever done this before, is quite a lot of tweaking with Cypher, and now it's basically being done completely automatically here from the UI. So this should take about, I think, like half a minute or something. There we go. All right, so it has just loaded all my data. So it automatically generated the cipher based on the CSV files. And you can even inspect that and see the cipher that it generated. It made some constraints, which is all very cool. I've not written any cipher yet. And now I'm going to jump into query and actually look at the data. So usually when I try Neo4j, the first thing that I want to do after a data load is inspect what I've done. So I'm going to use the text-to-cipher feature here. This generates a cipher query based on natural language. And you'll see here that it's using, I just type database schema, which is figured out, then that means this cipher query. Then you can indeed validate that the data was loaded exactly as the model had specified, which is, of course, nice. Text-to-cipher, if you ever use this in Aura, this has been improved a lot recently. So the way that cipher queries are generated is currently using a multi-hop agentic flow. So the queries are becoming much, much better. And you also see the new UI here in browser, right? So you see a different view. It's more based on an IDE tabbed experience. All right. Good. So I'm again using the text-to-cipher generation here. And in this case, I'm writing a little bit slightly more interesting query, starting with something simple like the names of suppliers. And again, it's going to look at the schema, create a query automatically, and then I can see the different suppliers here that have supplied the different products. I can also ask a little bit more difficult questions. Maybe I want to look at some statistics. In this case, number of batches for each product brand. And you'll see here that the AI has figured out then how to convert that into a valid cipher query. And then I can see that in this case, these are all fake products, but that one has been produced the most. Yeah. This is your data set, Alex. Do you recognize it? Yeah. Yeah. All right. So still, I have not written any code. Then I'm going into Bloom and just want to explore the graph with some free-form exploration. So in Bloom, you have this nice interface where you can type graph patterns. So you're just writing natural language, which then gets converted into a logical pattern matching query. In this case, recipe and a product. And then I want to inspect the product that I just selected, so the product with the most batches. With Bloom, that's then also going to create a graph, which I can then look at. I can inspect the nodes, see what the recipe is, and see what the different products are. And the nice thing about Bloom is that you get this free-form exploration where you can take any node, you can then right-click it, and walk outwards and see what else is connected, and kind of explore your graph as you go. And you can go as many levels deep as you'd like to, as you want to go. All right. Yeah, and if you haven't used Bloom before, there are also other things in here, like running algorithms. You can use graph layouts. It's got a lot of really nice visualization capabilities for graphs. Yeah, in this case, it's not really hierarchical data, but you can see some nice patterns here by viewing the graph in different ways. All right, so then I'm going into dashboards, and I would really like to generate a dashboard based on the data that was just loaded. So this is our new AI dashboard generation, which will look at your data, and then it will give you some suggestions for dashboards that you can create. So it gave me 3 kind of pre-cooked suggestions based on the model. I'm just going to select one of those and see what it produces. So what it's going to do now is create a plan. It's going to create a layout for a dashboard based on that requirement that I put in. And then you can inspect that layout before you have it generate all the queries automatically. All right, so this is now the dashboard shape that it has estimated. So it's going to create some summaries, some filters, some different chart types. And it all looks pretty good to me, so I'm just going to click Create. And what it's going to do now, again, using an LLM, it's going to build that page, combine the different queries, and structure them in a dashboard for you. All right, here we go. So this is a dashboard that it then has completely created autonomously, looking at how the different batches are produced over time, which locations are slowest in producing batches, some tables, and you see it has even created some filters here. Like it has, in this case, created a compliance page where you can select a different location and then a generation of a certain drug that it's creating. So it's actually, it's working pretty well, just out of the box. Of course, there will need to be a human that can then inspect and build on this dashboard. But as a first step, it's actually quite powerful for example, a business user to inspect their data. So finally, I'm going to create an agent. Again, I'm very lazy. I'm going to use AI to generate an agent. Again, going in blind is going to look at the model, look at the schema, and create an agent configuration. And what an agent effectively is a combination of tools. So you'll see here in a little bit, it's going to have different tools to run different cipher queries on the database, and then give you a chatbot where you can use that agent. Right. So here it has created an agent to give insights on products, which has these tools auto-generated, and each of these tools has a cipher query behind it. And then I can immediately start trying out the agent and ask questions. In this case, I'm asking about the same product that we had before, and the agent's now going to select the best possible tool for the job. So what it's doing here is it's choosing the natural language decipher tool, which means that it couldn't find a correct tool from the list. So I have to nudge the agent and tell him the word that I said is a brand name. And you'll see now that the agent is aware of, OK, I need to actually use this tool because the user is asking for a brand name. So still a little bit of nudging, but you'll see it autonomously then decides, OK, yeah, I need to use this tool to answer the question. Right? And you'll see here in a little bit, then this runs a cipher query in the background, and then gives you kind of a textual response based on the question that I asked. So we've really spent a lot of time here pulling this together, especially for first-time users. The barrier is now very, very low to load data, ask the first questions. Of course, you need to do some work yourself, but all these AI tools are really helping users get started with Neo4j and then share it with each other. All right. That was it for me. Thank you. Cool. All right, and then I'll hand over to Jean-Marc, who's going to be braver than me and do a live demo.
Yes, exactly. And yes, so I'm going to talk about document intelligence, or how to build a graph from unstructured data. So we discussed that this morning already with Alex. You have a lot of documents and a lot of knowledge that is trapped into this document. Alex had a better slide with all the type of documents that you have in pharma that you may want to use. And basically, the idea is you want an agent to be able to answer a lot of type of different questions coming from these documents. And to do that, well, 2 years ago, everybody was building vector-RAG approach, which means that you take your document, you chunk them, you compute embeddings, and then your agents have the ability to do similarity search, vector search on these chunks, and retrieve the most similar chunks to the query, and then from that, give an answer. So what we see is that it's OK if you don't have a lot of documents, and especially it's OK if the answers are contained in 1 or 2 particular chunks. But with this approach, it's very difficult to reason over a set of documents. Okay? The other thing is that when you reach accuracy plateau, it's quite difficult to improve your system. You can change the chunking size, you can change the embedding, you can use re-ranking, but yeah, then you're stuck and you need something else. And this something else, of course, is a graph. So the graph is the layer that is going to allow the agent to reason. So it connects all the different pieces of document together through nodes and relationships that can be extracted from the document themselves. So it provides better accuracy when you ask a question. And by the way, I can show you that. There was a paper published just this week, I think, from an independent research center, the Newcastle University, where they compared the accuracy from vector only and building a graph. But it's a very simple graph here. It's just a lexical graph. And so they published this. You can find it on our website. You can come to me if you need the link. In white papers from Neo4j.com. Okay, and what they show is that even with a simple graph, with the right tools, the agent is going to give more accurate answers consistently using a graph compared to a vector-only approach. So a graph type of approach, this reasoning layer, it allows also to give you traceability, because when you extract a graph from a document, well, you can link each fact that has been extracted to its source. And of course, it allows cross-document reasoning, and this is what I'm going to show. And at the end, it's faster to get an answer, and again, this is what I'm going to show. I put here token reduction because, well, it really depends. So it's difficult to say. What we see, for example, in the Newcastle paper is that it gives better accuracy with the same amount of token used. In the examples that I'm going to show, you can see the token reduction because when you ask a question, the LLM, the agent, is going to reason over the graph and not over the chunks. So it does not have to read the chunks to answer all your questions. But sometimes it has to. And so in that case, maybe it will use more tokens. So we are helping a lot of customers building this type of application in a lot of different verticals. So this morning, Alex already showed some use cases in healthcare and life science, but we are working in financial services, in manufacturing, engineering, technology, legal, etc., etc. For today, so I'm going to show you an example, and actually I didn't know, but this is exactly the example that Alex was showing this morning about Novo Nordisk. So what I did is that I asked Claude to download 14 investor decks or pipeline updates from 14 different pharma companies. And I'm going to use that to build a graph, and let's see what type of answer we can get when we ask a question. So again, Alex already explained why it's useful to have this type of question, but sorry. So it's very useful for you to be able to compare to what other companies are doing, who works on the specific molecules, etc., etc. The documents that I'm going to use, where I use that in purpose, they are quite complicated in a sense that, so let me show you an example here. Here. So this is, for example, the first one from AbbVie. So this is a PDF coming from presentation, and you can see that you have this kind of slide. So basically, with this type of document, you cannot just extract the text in hopes that the LLM is going to know what's inside this slide. You see that the layout is very important. You have columns, you have tables, you have colors, and it's a very dense slide. Okay? So the way to work with this type of slide, I see work quite well, is when you do the extraction, you're going to ask an LLM to extract information, a graph information from this slide. And the way it works is that you extract first the text, but you also extract an image, a snapshot of the slide. And when you provide the two to the very good result in terms of extraction. So for example, I know that in this slide, you have 51. It's because it's a slide that I use to benchmark the process, basically. I can show you another example. This one is from BMS. And so you see the type of data that we have. But you have this type of slide where you have information both in text that can be extracted, but also from images. You have the logo of the molecules here. So again, using an extraction that is multimodal, so both text and image allows to properly extract all the information here. Back to my presentation. So yeah, what I'm going to show is just an example. I don't work in pharma, so yeah, maybe there is some problem with the extraction, etc. I'm with Novo Nordisk and millions of documents. I'm using only 14 documents so that I can show you live how to do the. But if you want to productionize this, of course, you have to put more data, especially structured data, to constrain better the model. What I would recommend for people who want to get started with building this type of application is to start small. So first, understand what you want to do, what type of document you want to use, what type of question you want to ask, and define properly what are your constraints or the metrics that you want to use. Do you care about accuracy? care about reducing hallucination, token cost, etc. So when this is defined, and when you set maybe 10 or 20 questions that you want to answer, it's a lot easier to iterate and get a first graph and then iterate based on that. So yeah, my recommendation would be to start with 10, 20 questions. It's better if you have the answers already, then you can evaluate the accuracy. And from the questions and the document, now you can use an agent to define what should be the schema that you want to extract. Again, start with a small schema, and then you can iterate and grow your schema, grow your document after. Then you need to load the data in Neo4j, so load structured data and unstructured data. So the unstructured data, you will need to parse, if you're using PDF, for example. And there's different ways to do that. You can extract the text, you can extract the text and the image, or you can use more complex way where you want to keep the title, the sections, the subtitles, extract the image, the captions, etc. There is different ways, basically. But everything is possible here. So, and you can ask an agent, basically, to take this type of decision for you. And this is what I'm going to show just after. So once you have your, what we call the lexical graph in Neo4j, so the structure of the document as a graph, then you can chunk and you can extract the entities and the relationships from each chunk using the schema that you have defined previously. Okay? And then once you have that, you can validate. So there is different ways to validate what you have done. So you can ask an agent to answer the questions and then see if it gets the correct answers. But you can also ask the agent to look at the graph and do a deduplication report, for example, or ask it to find anomalies. And with this, you can iterate. Usually, it means that you can update the schema to give more definition or to use more granular definition of what you want to extract and how, and then you can iterate. Okay. So again, yeah, if you want to get started, start small and grow. So then you can iterate very quickly and at the end build the full pipeline for all your data. What I'm going to show today, so it's not, so we have a new product in Aura called the Neo4j Document Intelligence, and this is not what I'm going to show. So Neo4j Document Intelligence is a supported product you can use if you have access to it, where you can upload your documents and it's going to build a graph for you. You can prompt it to refine the. You have the nice interface to edit the schema that has been built, and then it's going to run the extraction. Here, I'm going to use a tool which encapsulates the methodology that I was showing. So we use that in the field, and this is a tool that we to build rapid graph prototypes. Okay, so it's made. So it's called the Neo4j MCP Workspace template. It's source. You can go to GitHub if you can read the. It's a bit cut, but if you can read the address at the bottom of the slide. So it's a GitHub repo that you can download, and you can install it very quickly, and it's made to be connected in your AI coding agent interface. So it works with Cloud Code, Cursor, Codex, OpenCode, and this is the agents that are going to take most of the decisions. In the workspace, you have 5 MCP servers. So MCP servers are ways to encapsulate tools you give to the agent, and the tools are going to be compatible with all the different types of agents. And so in these MCP servers, you have 5 main MCP servers. So one to give the agent the ability to build the schema and validate the schema. One to ingest structured data. One, which is the ingest MCP server. One to parse the PDF with different methodology to parse the PDF, the lexical MCP server. One to do the extraction, which is the entity MCP server. And the last one is called the GraphRAG MCP server. So it allows the agent to query the database with Cypher, but also to do full text and vector search in the database. It can also mix all these different retrieval methods into one query, and it can read images that are stored in the nodes. Okay? So it can do a lot of things. So now the agent have a lot of tools to build and validate the graph. And it has a skill. A skill, this is a document, a text document, that gives the ability to the agent to follow a workflow that you have defined. So we have defined for you this workflow. And so, for example, the first step will be to look at the data, then to identify what type of parsing method should be used to create the lexical graph, then start the interaction with the user to define the schema, etc., etc. So there is one skill. What I'm going to show is a used version of the skill. So I built a smaller skill to be able to show it live. But basically, that's also something that you can do. Now it's very easy to build your own skill based on your type of document and your type of questions that you're going to ask. The last thing is that it supports 100 plus LLM providers. So if you have a contract with OpenAI, with Azure, with Gemini, etc., you can use this tool to quickly build a graph. So now let me show you the demo. So yeah, I show you already the data that we're going to use. What you can see on the left is it's the MCP workspace. So when you download it, basically, this is what you have, is a lot of folders, and you have the code directly for the different MCP servers. You have a small setup script that allows to connect your agent to both the MCP servers and your Neo4j database. And then that's it, you can start it. So what I'm going to use, again, is 14 documents from the different pharma companies. And I have some structured data, which are more, for example, this one, structured data about metadata about the document. Okay? And now I can start. So let's start Claude. So I'm using Claude Code here. I already configured it. And let's go with the demo. So now, when I say that, it knows that it has a skill demo available, and it's loading the demo. I made it also, compared to the real skill, it's going to stop in order for me to explain what we're doing. But yeah, it can be fully automated, basically. So here, what we're going to use is GPT 5.4 mini for the extraction. So for the extraction, we recommend to use a smaller and fast model. We don't need reasoning. And we're going to use text embedding 3 small for the embeddings. Go. So yeah, I forgot to show, but yeah, I have an empty database here. And so now, at the same time, it's going to run in the background the lexical graph, and it's going to explain what we're going to do. So I already explained that this is a competitive intelligence graph for pharma company. And I cheated a bit. I already built the schema. So I ask it just to show you the schema. So it can write reports. And I don't know if you can see it here. So basically, what we have is a document is published by a company. A company has a drug in pipeline. A drug treats a disease that is part of a therapeutic area. A drug is in phase with a clinical phase, and it targets a biological target. And everything is linked back to the page, so the chunk where it belongs, where it was extracted from. OK? I can show you now it's done. So basically, we have our 14 document nodes here with the name, with the source, etc., with some metadata information. And each document is made of page. And each page contains both the text that has been extracted and the image that is saved as image basic. So you cannot visualize directly in a browser, but the agent can read that directly. Let me continue. So now it's going to load the structured data, which are very small. It's just linking each document to the company name. Okay. I also constrained with constrained vocabulary. So clinical phase, for example, I constrained the names of the possible values of clinical phase. And I constrained the therapeutic area. So this is what is, so you see, for example, hematology, neuroscience, etc. So this is what has been loaded. Let me continue. So now, this is the longer part. So it's going to extract from each page, from each image, the schema that we have defined. Okay? So it's doing that in parallel. So I have 50 calls at the same time. And so usually the speed depends more on the internet connection. So when I was trying, it was yesterday, it was doing that in 1 minute. I think here it's going to be a bit slower. But you can see that it's extracting a lot of information. So for example, here, the clinical phase from the document. Let me show you some drug nodes. So sometimes you just have the name, sometimes you also have the name of the developer, the formulation, the modality, and the status. So you can see that here. So I'm extracting also the disease with a name and a therapeutic area, clinical phase, and yeah, and I think that's it. And target. So the target can be the name and a target type. So here, protein, etc., etc. Okay. So it's still loading. So I know, for example, here it will reach 2000. So all this process is run in the background, so I can still talk to the agent. What I want to show you while we wait is that the schema that I'm using here is what I would recommend to use. So it's a Pydantic model that is quite refined. So I can specify, for example, when you run the extraction, if the extraction should only use a defined number of possible value, for example, therapeutic area or clinical phases. So I do that because I want to reduce the, maybe avoid. So there is a lot of ways to do that, and the agents are very good to normalize. So for example, this is what it built. So to use regex or to use a lot of different ways to normalize and make sure that you don't have duplicates at the end of the extraction. It's almost done now. There is still one page. But yeah, it will be the end anyway. So, so now that you have extracted a graph with 2,000 nodes and 5,000 relationships, now I'm going to see what type of question I can ask. Still doing. OK. So the last part is that I ask it to extract more, so to stitch basically the graph. So for example, the modality was extracted on the drug. Now it's going to extract it as a. All right. So last final check. So we have extracted 800 drugs from, where is that? 500 pages, 400 diseases, 200 biological targets, and we have the numbers. Okay. So now I'm going to use another agent to ask questions. So I have Cloud Desktop, and I have installed the Neo4j GraphRAG directly on it. And so, yeah. So first I'm going to check that it works. I removed all the other tools, so especially the internet access, because sometimes you ask question and it's going to look at the internet instead of the database. And so here I'm just checking that it has all the tools. Okay, so it has 7 tools available. It can read using Cypher. It can get the schema and the indexes from the database. It can do full text search. It can look at the images that are stored in the nodes. It can do vector search, and it can combine all this search together. Okay, let's ask what's inside the database. So it should use the first tool with the Neo4j schema. And it answers properly. It looks like a pharma biotech knowledge graph built from pipeline documents, PGX investor reports, etc. So here it has no other, and it uses only generic tools. But it can already understand quite a lot about what we have. So first question that I'm going to ask is to make sure that it runs a proper extraction. So the page from AbbVie that I showed you, now I'm asking it how many drugs it has on this. So it answers properly. So by the way, you can have the traceability here. The reasoning and the different tools that it is using with the different Cypher queries and the result it has access to. Okay? And from that, so it found the proper page, and then it counted the number of drugs, and properly it says 51 drugs extracted from this page. Okay, so now let's ask questions, broader questions, like look at the pipeline of each company and tell me where is each company placing its platform bets. Okay, so now you can compare companies together. So this type of question would be very, very difficult to do with a vector-only approach. So again, we can look in one Cypher query. It looked at drugs. Yes, it has access to the modality here. But basically, it classifies the different companies. So BMS is invested in small molecules, Novartis and Bayer as well. Doing biological antibody research, etc., etc. Okay. It also says that, yeah, I downloaded quickly the documents, so some documents are quite small. Of course, the accuracy of the answer is going to depend on the documents that we use. Then I can ask, okay, which single biological target has the most companies racing on it? And notice whether they're chasing the same disease or completely different one. So again, it's going to use a Cypher query here. And it finds BTK, so Bruton tyrosine kinase, 5 companies are racing on it: Eli Lilly, Novartis, Roche, AstraZeneca, and Sanofi. And what it found is that 5 companies, but they are not competing because they are splitting into different distinct battlegrounds. So some are using that for oncology, some multiple sclerosis, immunology, hematology, and autoimmune conditions. Okay, so it's quite interesting to have this over this type of data. What I can ask also is, if I want to visualize that as a graph, so I don't have a direct access yet between Cloud Desktop and Neo4j browser, but I can ask it to generate the Cypher query. And I'm going just to copy it and paste that here. Okay, and I can see the BTK target is here. I can see in blue the different drugs, in red the different companies, and in green the diseases that are in the documents. Okay. And I have a last question here. Let me show here. Sorry, Cloud Desktop. So I'm going to ask which company has a partnership for advanced AI capabilities. With which company? So this is not a question that we have extracted from. So it cannot use the graph to answer this type of question. But it has access to full text search, vector search. But here the real difficulty is that this answer is not directly in the text because the answer is in the image. It's using a logo. And I can show you, I ask it basically also to show me the slide. So it can read directly the image that is stored in the node in Neo4j, and it can display it to the user. And you can see that on the top right, you have OpenAI listed here. And because it's a logo, it was not extracted as text. So it has this advanced capability where you can ask questions, it can find its way to answer it, even if you have not extracted the graph around this specific entity. All right, the last thing that I wanted to show is I have the same here in Aura. Just to go back to what Niels was showing. Well, if I can, I want to connect to my database here. It's just that from this graph, we also build a quick dashboard. So, well, this is again exactly what Niels have shown. I want to say it's a pharma competitive intelligence. And based on my prompt, it's going to reduce the IDs that are suggested here. Do I want pipeline overview, competitive landscape, or target and therapy trends? I want competitive landscape. And I can create a nice dashboard about that. All right, so yeah, again, you can see you have the 14 companies, 900 drugs, and you have the drugs by modality, the drugs by development status, the top company by pipeline size. So again, it depends on what was in the documents, and you have the different tabs here available. All right, so yeah, for the moment, so this tool is open source. You can use it, download it. You just need basically an API key from one of the LLM provider. You can use also a local LLM, but it's going to be slower to use it. Right now, we're working on different ways to improve that. The first one would be to give it access to memory, so to store everything that is done and to keep the trace of all the decisions that are made as a graph. And once we do that, we can have this loop that I was showing. You can have this loop automated. So now, like Claude or OpenAI, they have the ability to use a slash command, which is a goal. So you can define a goal, and it's going to loop automatically and improve the model based on the questions that you ask, and refine the model, and at the end, build the best graph for you. Thank you.